Yeah, so I guess I'll get started since it's 3 o'clock and all. Who am I? Why am I here? My name is Mike Barreta. I'm a solutions architect with Elastic. I've had a number of jobs in the past. The list is long but distinguished. Started out in college doing help desk stuff, so I know what that's like. Joined a system integrator, formerly known as SRA, out of college, doing software development. 10 years or so, moved on to consulting, where I spent time doing what consultants do, but in a more technical side, finding data, collecting data, massaging data, doing data analytics, and presenting results, which is where this, quote, data science comes from. And recently, I've been doing more things on the sales side, which sounds kind of grimy, but I think sales is really a kind of good mix of engineering and consulting. It's solving technical problems, but in order to solve a technical problem, you have to really dig to find out what the problem actually is. And then the engineering part is there to try to solve it. So, yeah, why am I here? What's my purpose was the point of that. So I'm going to talk about logging from Kubernetes environments in an automated, centralized, and scalable way. So why should you care about Kubernetes? I guess I should move out from behind the desk. Hopefully I don't have to convince you of this at this point. I mean, we're at the end of the day. You guys have probably been hearing a lot about Kubernetes, a lot about containers, a lot about the benefits. But suffice to say, I think containers are here to stay. I did some quick research, which is to say like 5 minutes on Google. Found a report from Datadog that said, that was back in 2017, they saw a 40% growth among their customers in Docker adoption between 2016 and 2017. RightScale did the same type of thing in 2018, saw about the same 40% growth between 2017 and 2018. At 40% annual growth, you end up doubling about every 2 years. So essentially by 2020, we should have twice the number of people using it as today. By 2022, it'll be 0 people because it'll be obsolete. A lot of corporate backing, i.e. Red Hat and others. And of course, an engaged community. Why Kubernetes? Because something like containers need orchestration. Again, I don't think I need to sell you guys on this because it's valuable. And in the end here, if you can't see, I think I'm going to make the bold statement that says Kubernetes is going to win the orchestration wars, mainly because their competitors are all embedding Kubernetes inside themselves. And like Alien, it's going to burst out from the host, and yeah, never mind that. What is a container? Again, I'm going to go fast through these. I think you probably have heard this a number of times today, and do enjoy my fun animation. You know, you build enough decks, and sometimes you need to entertain yourself. So each one has a little different. Yeah. So what's a container? You know, that's a container. A container is a combination of an application plus its dependencies and hopefully nothing else. And hopefully that application is also kind of tight and small. Whereas something like a VM, you package multiple applications together with its operating system. In the container world, you try to keep these things pretty distinct, single purpose, Unix philosophy, that kind of thing. Again, I don't want to belabor the point. Kubernetes, same type of thing, going to go really fast on this page. I'm not entirely sure why I chose to include them, but so it goes. Kubernetes then is an orchestrator for these containers. Given requirements of what I want to deploy and how many, Kubernetes will try to find those resources among the hardware that is configured to manage, and do a bunch of other cool things like load balancing, scaling, logging, which I'll talk about, etc. Don't worry too much about the terminology. The one I want to call out is a daemon set, because that's going to be the linchpin of what I'm arguing for. A daemon set is a way to ensure that a given container is attached to every deployed pod within Kubernetes. And that's very important because we're going to make use of that to put, which you'll see in a second, I don't want to give it away, to put some kind of logging piece into every pod that's run. Yeah. So we're at the root problem here is we have this containerized environment. You're probably running tens, if not hundreds of different applications, each with numerous different containers across lots of different hardware. And you end up with a lot of kinds of questions that you want to be able to answer. One might just be around Kubernetes itself. How is it performing? You know, how many resources are there available within it? Are there pods that we're being asked to deploy, but there's no more room for them, or they failed to deploy for some reason? At the pod level, at the node level, what's that node? Where is it? What rack is it in? What is its IP address? How much space does it have left on it? In each application, you have questions around those applications. If it's a web application, for example, who's querying it? You know, who's hitting that endpoint? How many times are they doing it? Where are they coming from? do I need to scale up or scale down for that application, right? There's all these kind of questions you have to answer. And if you haven't discovered yet, having all that data in one place makes answering questions a lot easier. If you have to go between different systems in order to figure out when a pod failed to deploy, I can go to Kubernetes, for example, and see that a pod failed to deploy. But understanding the impact of, at the same time, I'm getting a bunch of trouble tickets because my web application is now responding slowly, and being able to correlate those things together to find out that I tried to scale, the scale failed, why did it run out of resources, all these things, when the logs are brought into a single place, they're a lot easier to answer. So the solution to this problem is Belk, which is actually not a thing, so I'll describe what I mean. But if you're familiar, there's an open source stack called Elk, which is Elasticsearch, Log, Stash, Kibana. There is a fourth component within our stack called Beats, which is where this little B comes from. And that's what we're going to focus on. So real fast to go through what this open source stack is. Kibana is a user interface that sits on top, all web-based. It does data visualization. It does some management pieces. It does some analytics. It's tightly coupled with Elasticsearch, which is the search and analytic engine. Hopefully, has anybody here not heard of Elasticsearch? Show me your ignorance. No, I'm kidding. So that's the heart of the whole thing. And then at the bottom is this ETL layer, Logstash, which is a server-side component to pull data in from a variety of sources, do a lot of transformations, and output also to a variety of sources, but normally Elasticsearch. Beats, which not everybody's heard of, Beats are lightweight data shippers, call them agents, written in Go, that live wherever the data is generated. So they're meant to be deployed into a variety of things. Underneath it is a open source component called libbeat, which is also in Go. So you can extend it and create your own. There's actually, I don't remember the count, 20s, 30s, 50s or so community contributed beats so far. XPack is a commercial extension written by the company I work for, Elastic, that bolts on into the open source stack. Just to mention here, it's currently open code. Yep.
So does Beats feed directly into Elasticsearch, or does it go through Logstash to get to Elasticsearch?
So the question is, does Beats feed into Elasticsearch, or does it have to go through Logstash first? It does both. It actually can also connect into a layer like Kafka or Redis. We'll talk a little bit about architecture in a second on that front. So yeah, XPack, the code is currently open. This is a change. I'm not going to belabor the point on this one either. If you're interested in learning about our open code with XPack, just search for opening XPack. You'll find our blog posts about it and all that kind of stuff. I'm also not going to talk too much about XPack, but it's valuable. You should check it out. So this is the current Beats family that we have. These are all the ones we created. Again, I mentioned there's community Beats, but these are our Beats. FileBeat is essentially a log tailer. Point it to a log file, it tails it. Metric Beat collects metrics from the system. Think of CPU, RAM, disk levels, but it also metrics from specific applications. So if it's hooked up to something like a MySQL database, it can pull the metrics that MySQL reports. So transactions per second or whatever else it's cache hits. Packet Beat is network data. So given data over a network card or whatever over the wire, it'll figure out what the protocol is and parse it appropriately. WinLogBeat lives on Windows machines and sucks in Windows events. So I shouldn't say sucks in, throws out Windows events. AuditBeat brings in auditd from Linux. If you guys are familiar with what auditd is, it just reads all that into Elasticsearch. And then last is Heartbeat, which just does kind of what Nagios does, checks to see if things are alive. So this is what we're going to kind of demonstrate if I go fast enough, which I'm on pace to do, to show you how this will all work. But the key here again is this daemon set. So in this little example, there's a single node being managed by Kubernetes. We have 3 different pods. Each pod has 2 containers, one being an Apache web server, and it's talking to a Redis database, for lack of a better term for it. This is actually going to be based on the Kubernetes guestbook example. If you ever download Kubernetes, there's a guestbook app that is going to do this for us. But you'll see, again, by registering FileBeat and MetricBeat as a daemon set, they'll automatically get attached to each of these pods, start pumping data into Elasticsearch directly, not through Logstash in this case, and into Kibana. So how are we going to accomplish this? There is a feature within Beats called modules, and modules do a number of these steps for you. So the first step here is creating an ingest pipeline inside of Elasticsearch. Elasticsearch, along with storing data and retrieving data, also has a lightweight ETL piece built into it we call ingest node. So it'll do things, in this case, like take the IP logs from the web server, and do a geo-IP lookup on it so that you have a lat long associated with an IP so you can map where your users are coming from. So it's going to, these modules will create that ingest node pipeline. It'll create the mapping inside of Elasticsearch to figure out which fields it's going to capture, what type each of those fields are, so that when you ingest it into Elasticsearch, all the magic of having to define your fields and figure out what data types they are will be done for you. It'll create visualizations inside of Kibana, so you'll get all the cool bar charts and maps and gauges, etc. done, and it'll take those visualizations and arrange them in a nice, pretty dashboard, which of course you can edit, but at least out of the box you have something. So without much work on your part, you get a full-featured raw data to living dashboard pipeline tailored towards different kinds of applications. What kinds of applications? Oh, did you see that? One thing that missed. Anyway. So on FileBeat, we have a number of different modules we support. You can kind of read these. There's things like Kafka, MySQL, Postgres, etc. So the idea being that FileBeat will understand where those logs tend to be written. It'll understand those log formats, and it'll be able to parse them appropriately without you having to do any work. Ditto MetricBeat down below, which does support a lot more applications because a lot more applications have a standard way of pulling metrics from them. So we support a bunch of these different things. And that's where this automatic logging is going to come from. Because when you deploy applications into Kubernetes, not always, of course, but often they're of these types. And so with FileBeats and with MetricBeats, you're going to get an automatic way to find them, parse them, and build dashboards from them. The other piece of this solution then is what we call metadata processors. So since we're living inside of a Docker world and a container world, there's information that we want to be able to pull out of those applications. It's not just good enough to say I'm running an Apache web server. I want to know what container that's in. I want to know what pod that container is in. I want to get all this metadata. So Beats has these metadata processors, and we're going to take care of turning those on. Boom. And the last step is auto discovery. And this is somewhat new, and this comes to us through work from eBay, who's actually a major contributor to the Beats code, because they have an enormous infrastructure. So auto discovery is a way to automatically turn on a module given some event. If the event occurs inside Docker, you have a couple different ways to build logic to turn on that module. So given some kind of container ID, you can trigger a module to turn on given some kind of image or container name or container label. So with this metadata, you can do a quick kind of if statement, essentially, and say, if this, then turn on this module. Ditto Kubernetes, these are, and this is probably more valuable to you guys after the fact than right now, but these are the different fields you'll get from the auto-discovery capability that you can build this if-else logic on to turn on a certain module. So again, the magic here is by deploying this as a daemon set and by using our modules plus auto-discovery, when you deploy some new pod or scale up or scale down, the Beats will automatically run. They'll automatically detect what is going on, what event has fired, what app you're running, automatically turn on the right module, automatically start collecting, parsing, and building dashboards for you. So essentially, for nothing, you get everything. And hopefully, again, I'll be able to demo this. This is kind of ugly, but I'll step through it real quick. This is the config file for this daemon set for FileBeat. So what you're looking at here is a config map, which is a Kubernetes configuration. You pass the FileBeat, kind of right in the light there. You pass the FileBeat configuration in there, so it's kind of passed through. But I'm turning on this setup step, which is what actually does the create dashboards, create templates inside of Elasticsearch. By default, it's turned to false, so you kind of turned on to true. I'm setting up a certain module. This is the system module, which is a default module to pull just syslog out of the container it's in. Beyond that, I'm turning on this auto-discover I talked about. I'm using the Kubernetes auto-discover, because I'm not just doing this from Docker, but I'm monitoring Kubernetes events to do this auto-discover. This one turns on for the Redis app, but you can see one down here also, which we do it for the Apache module. So I'm saying when Kubernetes launches a container with the label front end on it, then I will trigger my Apache 2 module. So it's pretty straightforward to see the kind of if logic, right? If the condition, if the label contains front end, then kick off Apache module. It's also going to make use of a Docker prospector. What that means is, different environments put logs in different places. Docker has a certain place they tend to put their logs. It's like var, lib, Docker containers. This prospector knows that, and so it'll look for the logs in the right place. Lastly, here's those metadata processors I talked about. We're turning on 3 of them, the Kubernetes one, the Docker one, and another one called Cloud. You may or may not see it, but the idea is if you're running in AWS or running in GCP, it knows that, and it'll pull relevant things like the instance type and the instance name and things like that out of, and add all that to the log. So the whole idea here is you're enriching every log line with all this metadata. And lastly is dumping this into Elastic Cloud, which I'll show you in a second. Those are just the configurations to connect to Elastic Cloud. I'm going to point this out because this is the directions I'm going to follow. We have an example repo on GitHub called Monitoring Kubernetes, cleverly enough. It has this file in it, and it has all the other stuff I'm about to show. So tying it all together. So step 1, of course, is to actually install everything. So install Elasticsearch, install Kubernetes. I'm not going to do that. We're going to assume it's already been done. The next step is to actually create the Elasticsearch cluster and turn on Kibana. Cloud.elastic.co. So let's see if this is simple to show. If you go to cloud.elastic.co, it is trivial to create an account. So if you click down here, say sign up now, all you have to do is put in an email address once it finishes loading, and it'll send you an email with a temporary password. You have a 14-day free trial for a cluster. It's what I use. Of course, it's free for me for longer than 14 days, but so it goes. Yes, so first step is creating a cluster. I'll show you what I did. I already created one, but just to give you a quick view of what that looks like. You create a deployment. It's very simple. You give it a name. You tell it how big you want it to be. In this case, just choosing this 4 gig. Which platform to run it on, AWS or GCP, what region it should live on. You can tell it to deploy it across multiple zones. 1 zone for, call it development testing, up to 3 zones for full production mission critical capability. What version of Elasticsearch we're running, what plugins you want to install, some configuration stuff, and then you hit create, and it's done. So of course, again, I've already done this. I have a DevNation cluster. So this is the interface for Elastic Cloud again. When you get a cluster on Elastic Cloud, you get endpoints. This is my Elasticsearch endpoint. That's my Kibana endpoint. And here's this Cloud ID, which makes it easier to configure beats. That's its whole point, really, is just to make it easy to configure beats. You'll see that I only have one little node running, this one 4 gig node, and one little Kibana node. So that's that environment. I've already gone through and set up Kubernetes as well. So this is the Google Cloud Platform Kubernetes, the GKE, I think it's called, running with 3 nodes. So that's that. So the next step then is actually to start typing. Again, I'm going to follow this monitoring Kubernetes, which is here. All right. So this goes step by step through pulling off this little demo where you're going to do some things like this authorization step in order to be able to deploy stuff. Can you tell? Yeah, you can kind of see this. Where you create this role binding, I've already done this. This is where it's actually getting all this code from GitHub. We've already done that. Setting some credentials. So I mentioned getting this Cloud ID from Google Cloud and you get a default Elastic password, user and password. So you have to set this in order to create a secret inside Kubernetes. It's just good practice if you're doing password stuff to use Kubernetes secrets instead of trying to pass that information directly into a container, or worse, embedding it in the container. Kubernetes, there's a project called Kube State Metrics. This is a Kubernetes add-on, but it generates cluster level and pod level metrics. We're going to use this in order to pull that data into Elasticsearch, into Kibana. So part of the steps in the setup here is making sure it's running. If it's not, you go ahead and create it. That's what these steps are. Again, we're not going to do that. We're going to start here with the guestbook example, though. So I mentioned that this is all based on the Kubernetes example, this guestbook. So first step is to go ahead and create, get this bigger too. Yes. To deploy it, and let's assume this is all going to work perfectly. There we go. So as that deploys, the next step is actually to get the IP that it spins up. It creates a load balancer inside of Kubernetes, which will take a second in order to give us an external IP, because I'm going to need that in 1 second. So while this deploys, I guess any questions as we go? I know I'm moving kind of fast. I tend to go pretty fast on this stuff. It's hard to make that readable, isn't it? There we go. If it's slow, you can blame Google. This is not my fault. Let's see, while this spins up in the meantime, once it's done spinning up, what we're going to do then is move down to this daemon set piece. Actually, I think I was going to skip. I kind of switched 3 and 4 here. I already deployed the apps. That's what we're watching down here is to deploy app pods. So once this is complete, the next step then is to create the actual daemon set piece, which if you've seen this example, not just my example, but through some of these others, it's that pretty simple step of just hitting the create. There we go. The kubectl create. All right, so let's go into, I think it used to be this one. Yeah, so there's our guest book. Just to generate some information, firsties, yes, and foo. So it's a bad app. It doesn't actually let you submit by hitting enter. Foo bar. All right, so a little bit of traffic in there. Next step, like I said, we're going to do the kubectl create. Let's do file beat first. I typed that wrong. And then we can do metric beat. All right, so now we've done this, right? So in theory, if this is all working right, I'm going to jump into Kibana, and we should see data flowing in. I haven't done anything, right? I've just defined these two. I've just created these 2 daemon set containers, definitions. And hopefully, if everything works out right, we'll start getting data. And not just any kind of data, but data that's been tailored towards those particular applications we just deployed. Sweet. All right, so let's make this nice and big for you all to see. Of course, geez, that was a bit too big. And let's collapse this out. All right, so let's see what we're getting here. So right now this is file beat data. If anybody used Kibana before, you should recognize what these patterns are. So all my file beat data goes into file beat. All my metric beat data goes into this metric beat pattern. And at one point, it actually run packet beat. That's why this is here. So file beat, we get all these different log lines. I'm actually going to pause this so I can make it easier to show what we've got. So what do we got? This is a document from Redis. This is the Redis module from its slow log. I'm not actually a Redis master, so I can't tell you too much about this, but you can see the Kubernetes metadata I talked about. Here's the Kubernetes container name it came from, the app label, the pod that it's in. Here's that cloud stuff I talked about. So it's from this GKE instance inside of Google Cloud. You got the project ID that I'm running under, and here's the provider, right? Let's see if we can get a, actually I'll use some of this handy foo from Kubernetes. I want to find a non-Redis log, right? So I can actually filter out values just by clicking. So I want to filter out all the Redis data, which should give us just the other stuff. So let's see what this one is. This is an Apache log, which is exactly what I want. So I have stuff like the remote IP that the data came from, the response code for the request, the URL that was hit. So let's start adding some of these as columns. I want to see the IP. I want to see the response code. I want to see the URL. Let's see about the host it came from, and maybe something Kubernetes specific, like the pod it was in. So I just added all those columns. So now I have a little prettier table to deal with. So what was interesting actually looking at this is you see all this server status, all these hits, which is not what I was doing, right? I was submitting stuff to the guest book, but I'm getting all this server status. And what this actually is metric beat. Metric beat to collect data from Apache is hitting this server status endpoint, parsing the stats it provides, and dumps it into Elasticsearch. So that's interesting and all, but I don't care about that, so I'm going to filter that one out too. And so what we get are the guest book entries, which is what I entered. So yeah, I have my log lines. You can see when those requests happened. And we're going to go a little further. First, I want to do something like pin this. And you'll see what the value is this in a second. But I'm going to pin it to the bar. So when I pivot over to dashboards, let's actually open up the file beat. This is the Apache. This filter is still there. So by pinning a filter in Kibana, it means it's active across all the different applications inside Kibana. It just makes it easier to keep consistent views across the data. So looking at this, you can see, we did that GeoIP lookup. My IP was referenced into this lat long, so we can see that my request came from here. Now sometimes, if this is left up long enough, it doesn't take too long usually. In fact, let me do a quick turn back on. It pops up from usually some Central European nation where people are there's a botnet swarming and looking for open ports and looking for deployed applications, and you'll end up getting pings for things like PHP MyAdmin, for example. They just hit, and I saw that yesterday, but looks like I'm not going to get lucky and see it today. So this is the Apache module dashboard that I talked about. It gets built for you automatically, so you get a map of all the IPs and where they went. You see the counts of those requests over time, along with errors. So actually, this is interesting, a 404 error, which was not through there. So I wonder if we can add, 1 second, bear with me. I think I have, did I create it yesterday? Nice. I created a visualization, just a simple data table yesterday that puts the count of each IP by the number of requests it made. So I just added that into the bottom of my dashboard. Yeah, so 7.4 got a 404. Was that me? So hold on. What's my IP? .122.25. That was me. So somehow I ended up with a 404. I'm not exactly sure how. But this is what you get by having all the data in one place again. So I have this dashboard that has all my Apache information in it, again, broken out by response codes. You can see any errors that happen to show up. If we get rid of this pin, at least disable it for a second, disable this for a second, we'll get the full set of requests at that endpoint. So you see all the different status calls. We have a bunch here. We have a Kubernetes one, Kubernetes overview for metric beat. So you see that I have these 3 nodes that are running. You can see how many deployments there are. These are all the things, not just that I've deployed, but that are internal to Kubernetes itself. Here they are broken out. If I were to expand to scale up, for example, that Apache service and add 2 or 3 new replicas, you'd see that reflected here. You'd see the count jump up. Just other data. So this was when a pod was being deployed and was currently listed as unavailable. So you can see that in here. CPU usage, memory usage across all your pods. I mentioned Redis. Let's see if there's a Redis dashboard. One at file beat, one at metric beat. So here's our file beat. Default dashboard. Again, all the different messages that are coming out of it. The type of log event that it was. Log levels, etc. So again, just to, because I think I'm out of time, without much effort at all, just by defining these things, which you can get for free, right? I showed you the example configuration. It's all there for you. You get data from raw to dashboard. It flows in automatically. As I expand or contract my environment, my logging will keep up. A lot for nothing. It's usually a pretty good deal that way. Although there's no such thing as a free lunch, but ignore that for now. Yeah, I guess that's it. Any questions? Yeah, well, I'll be floating around for a little bit, so feel free to hit me up. Thank you.
Great, thank you.